Hello everyone, networks basics and what is sockets. Now, what is the network? The network is a computers and devices connected to each other with wires or wireless, which is Wi-Fi. Now, the internet is a big network that uses telephone lines, cables, satellites, and wireless connections to connect computers and other devices. Now, how internet works. Now look at this image. Okay. Now this is your computer or my computer. Now my computer has this specific IP address, which is the internet protocol. That's the identifier of my computer on the internet. Now I have this IP address. Now I am connected to my router or my switch here, as you see. Now this is connected to my ISP, which is the internet service provider. Okay. Now this is the internet, as you see here. Now I am connected to my router. Then again I am connected to my ISP. The ISP I found or I have here have or has routers or many routers. Now with an its routers that connected to other routers, okay, or to other ISPs. This is ISP hierarchical from regional to international and so on. Okay, now I will not handle the small details. Okay, now my router here, as you see, connected to here another router and to another router, another one, until I reach this specific server. For example, udemy.com. So again, udemy.com will reply with the same route I have to reach the or to reach my computer. Okay. Now, of course, there will be DNS's services to make a better way or to optimize your path and so on, and other factors like which way is the better, um, which algorithm that specific routers use. It depends in which area you are, the restriction, the policies, and so on. Okay, now this is the routers, this is switches, wires. As you see, this is RJ45 twisted there, and this is the fiber. Now, now if the server is located online, how this will works? Now, as you see, this is client 1, 2, 3. Now, and we have this server. Now, client 1, as you see here, connected to the we connect to the internet until we reach our server, as we mentioned before. Okay. Now let's assume that we are client 1. Okay, we are on the client 1, 2, 3 that are connected to the internet. They are on a different networks. Okay, now this is the scenario right now, and this is if the server is located online. Client 1 connect to the internet until we reach server. This is a simple image just to explain. Now this is if the server is located offline. Now all the clients, as you see here, 2 laptops, 1 mobile phone or smartphone here, and 1 desktop, connected to the same server and the same let's say office or building or the same room, and so etc. Okay, now we are connected to the same server or to the same router and or switch or any and so on. Okay, as you see here is the database. Okay, now if I want to connect to another client, I have to get through this server and so on. Now let's start with the OSI model, which is Open System Interconnections. Now we have, what is OSI model? It is a model that's been created which with many layers, okay, to tell us how the data being transferred. Okay, now we will start from the application. As you see, this is the user or the browser. Okay, the application layer to the presentation, session, transport, network, data link, physical, until we reach the physical link, until we reach the data. The other one is, see it like this: physical, data link, network, transport, session, presentation, application. Now each layer has many protocols, each layer has specific data or and each layer has a specific functionality. Now I will not handle all the small details here. If you want, you can write or open Google and Google it. Okay, But in a brief way, application has protocols like HTTP, FTP. Okay, here the presentation. This layer responsible for converting the data or the extension .exe, mp4, mp3, and so on. This is the session to make a session and connection between two users or from user to client and so on. This is the transport layer. We have two main protocols here, the TCP and UDP in transport layer. The network layer here, the IP protocol will be here, okay, which is the internet protocol. Data link layer, this is the switch. As you see, I forget to mention that the network is the layer for router, but the data link is the layer for switch. And as you see here, the physical link or the physical layer that translate the data from digital data to analog or to signal data and transfer it to the links. Okay, now what is socket? Now socket is a communication mechanism that allows client or servers to connect to each other with a specific rules. Okay, so the socket, from its name, it's let's say it's a bucket with a specific rules. We take it and from client and send it to the server. As you see, bucket, you put inside what you want and you send it. Okay, now the socket programming is a way of connecting two nodes of a network to communicate with each other. Now server forms the listener socket while the client reach out to the server. Now this is the scenario. As you see, this is the socket. This is the server, as you see here, and this is the client. Now the server creates a socket, set the socket options, and it is binding right now and listening. Now the client create a socket and connect to this listen socket. And as you see, the server here will accept it. Now we have communication between the server and client. We will start by sending and receiving. Now the types of a protocol. We have TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Now, what is the difference between them? Now, this is a simple image. Now, TCP is reliable, UDP is unreliable. TCP is connection oriented, UDP is connectionless. TCP segment retransmission and flow control through windowing, okay. UDP no windowing or no retransmission. TCP has segment sequencing to make sure that we have the right order of the connections. But no, UDP has no sequencing at all. TCP has acknowledged segments. UDP has no acknowledgement. So UDP is best effort protocol. Some say is not a best effort, but let's say it's a best effort. A best effort means that no guarantee at all. No congestion control, no flow control, no transmission, no transmission acknowledgement, no segmentation, sequencing, and so on. So it is unreliable, but it is much faster. So TCP versus UDP, TCP is much safer, but it is slower. UDP is much faster, but it is unsafe somehow. Okay, TCP versus UDP communication. As you see, this is the TCP. As this image is as um, a socket programming point of view. Okay, now look at this TCP on the left. Sender, receiver. Now sender start by doing this. Send. The receiver will respond by send ACK. The sender will respond with ACK. Now we started the connection until the receiver, or the receiver means the server, okay, and this is the sender close the connection, or the server close the connection. But in UDP, look at this. The sender request, the receiver response. The sender respond. As you see, this is response and request response, request response. No three-way handshaking or no send ACK. Okay. Now this means that this is we start sending and receiving data without making a connections. Now as you see, it is much faster, but it is unsafe. One, now UDP has many uses and TCP has many uses. Now DNS domain name server use UDP because it is much faster. Some use TCP. Now, but that the TCP being used in FTP, for example, or in HTTP or HTTPS. Okay, so every protocol has many uses. Now, there is another thing is called raw sockets. Now, what is the raw socket? Now, raw sockets is an internet socket that allows direct sending and receiving of internet protocols packet without any protocol specific transport layer formatting. So we will not use neither this TCP or UDP. Just we sending and receiving without any protocols. Now this is very important. This raw socket being used by hackers in specifically in DDoS attacks. Okay, now DDoS attacks is a concern right now in the real life, in the real time, or in this time. Now, DDoS attack or DDoS stands for Distributed Denial of Services. Now, this is how DDoS works, but in a brief way. Now, this is a hacker, as you see, number one. The hacker has controlled many zombie computers or bots, we call it. The zombie computers control many other computers called reflector. And now, as you see, this is the target. All the reflector will start sending packets, and this will be this will congest and exhaust the target. Now, this is one of the scenarios in DDoS. Now, there's another scenarios like using TCP retransmission, TCP segmentation. We will use DNS amplifications. We will use IP spoofing and so on. But this is a scenario on a reflection. If I use another computer use another computer to this computer, as you see, is injected with in a malicious code. So we will do what the zombie computer tell him. Now remember, the only true wisdom is in knowing you know nothing. This is Socrates. Thank you today.